February the 8th through the 12th. We're doing lesson 25. Our lesson is entitled Solving Problems in Two Ways, Rates and Algebra. So our goal is to investigate a problem that can be solved by reasoning quantitatively and by creating equations in one variable. We're also going to look at how to compare the numerical approach to the algebraic approach. Alright, so let's look at this. Solve the following problem first using a tape diagram and then using an equation. In a school choir, half of the members were girls. At the end of the year, 3 boys left the choir, and the ratio of boys to girls became 3 to 4. How many boys remained in the choir? Alright, so it tells me to first use a tape diagram. Alright, so it says half of the members were girls, and so that means the other half were boys. So using the tape diagram, this is what I'm going to look like. So I'm going to draw a tape diagram here. And we've got, this is what we started with. Okay, so here's our boys. Here's our girls. Okay? Now it says at the end of the year, 3 boys left the choir. Alright? So we're going to just kind of section this off, and we're going to let that be 3 boys. Okay? At the end of the year, the ratio of boys to girls became 3 to 4 once those 3 boys left. So let's think about this. So this was initially, in other words, that's when we started. And then at the end of the year, this is what it's going to look like. It said we had a ratio of 3 to 4. Alright, so my girls are 3 to 4. Okay? Now, so here's what I need to know. Alright, so this is the unit that left, and that was 3 boys that left. So 1 unit equals 3 boys. Alright, so 3 units would be 3, 6, 9 boys. Alright, so there were 9 boys in the choir. Alright, now, it wants us to use an equation. Alright, so using an equation. So the number of boys initially, we'll let be B. And the number of girls initially, because it was the same. Okay? At the beginning, it was the same amount. Okay, so now the number of boys at the end of the year would be B minus 3, because 3 boys left. Alright, so the ratio of boys to girls at the end of the year was 3 to 4. How to spell. Okay, so the ratio of boys to girls at the end was b minus 3 to b is equal to 3 to 4. Okay? So now, let's talk about how we're going to do this. So I can set this up as a ratio. Okay? So my boys to girls. So at the end of the year, the boys was b minus 3 over the number of girls, which was b. And we can set that equal to the ratio is 3 to 4. Alright? So now I can multiply. Alright? You can do this a couple of different ways. I would multiply both sides by b. Alright? When I do that, I get b minus 3 is equal to 3/4 b. Alright? I can subtract 3/4, and I'm doing this so I can keep it positive. So I get 1/4 b minus 3 is equal to 0. Add my 3 to both sides. And I get 1/4 b is equal to 3. Alright, now, best way to do this, instead of trying to divide by fractions, multiply by 4. So I get b is equal to 12. Alright, so think about this, guys. B is the number of girls. So there were 12 girls, which means 12 minus 3 means there were 9 boys at the end. And I figured that out using my tape diagram. Okay? Which problem solution, the one using a tape diagram or the one using an equation, was easier to set up and solve? Why? Guys, this is a question for yourself. Which one did you find easier? Was it easier to do tape diagram, or was it easier to do the equation part? Your choice. I would like for you to answer this. I will look for an answer when I grade your packets. Alright, let's look at number 2. Okay, so number 2 says, all the printing presses at the print shop were scheduled to make copies of a novel and a cookbook. They were to print the same number of copies of each book, but the novel had twice as many pages as the cookbook. All of the printing presses worked for the first day on the larger book, turning out novels. Then on day 2, the presses were split into 2 equally sized groups. The first group continued printing copies of the novel and finished printing all the copies by the evening of the second day. The second group worked on the cookbook but did not finish by evening. One printing press working for 2 additional full days finished printing the remaining copies of the cookbooks. If all printing presses printing pages for both the novel and the cookbook at the same constant rate, how many printing presses are there at the print shop? Okay, so this is a huge paragraph and kind of crazy. So let's just kind of break it down and talk about it. So what's the story about? The story is about printing novels and cookbooks. Will more novels be printed than cookbooks or less? It says neither. It says the same number of each will be printed. How many pages does the novel have compared to the cookbook? Well, if you go back and look, it tells you that that the novel has twice as many pages as the cookbook. So how much longer would one printing press take to print a novel versus a cookbook? It's going to take twice as long to print a novel as it is a cookbook. Is it important to know how many pages each book has, or how many of each book will need to be printed? Not really. How many of the printing presses are used to print the novel on the first day? All of them. How many of the printing presses are used to print the novel on the second day? Only half of them. Okay. How many of the printing presses are used to print the cookbook on the second day? 1/2 of them. How many printing presses are used to print the remainder of the cookbooks on the third and fourth days? 1. How many printing presses could be used to print the remainder of the cookbooks in 1 day instead of 2? 2 printing presses could have finished the cookbooks on the third day. So what are we trying to find in this problem? We are trying to find the number of printing presses at the print shop. Okay, so solve the problem working with rates to set up a tape diagram or an area model. So one of the keys, or somewhat to a simple solution, would be what we call an area model. We need to recognize that the novel has twice as many pages as the cookbook. So the area that represents the novel should be twice the size as the area of the cookbook. Okay? So, let's look at what this is going to look like. Okay, so this will be our novel. Okay? And this will be our cookbook. And we said that the novel is twice as big as the cookbook. Okay, so on the first day, all printing presses were used on printing copies of the novel. And on the second day, half completed the novel while half worked on the cookbook. Okay, so let's think about this for a second. On the first day, all the printing presses were used on printing copies of the novel. Alright, so on day 1, all printers were used. So we're going to divide this into the number of printers. Or we're going to divide this among printers. And we will talk about why we're doing this here in just a little bit. Alright, so our novel. Alright, so we're going to label this day 1. And that was all printers. Okay. We're going to label this day 2. And that was half printers on the novel. And half printers on the cookbook. And I'm just going to label it CB. Okay, so if all printing presses completed half of the novel job on day 1, then half the printing presses would only complete 1/4 of the job on day 2. Therefore, only 3/4 of the novel job would be completed by the end of day 2. But the story says the whole novel job is complete by the end of day 2. So something's not quite right here. Okay? What we need to understand is that the novel job must be split into thirds. Alright? So we're going to label the novel job the whole unit. And each third of the fractional unit is 1/3 of the whole. Alright? So, we're going to label our novel as our whole unit. And our cookbook is going to be 1/2 of the whole. All right. Each of the small rectangles in the picture represent how much of the whole job, or the novel job, one printing press can do in one day. Drawing in small rectangle units for the rest of the diagram, we see that 8 printing presses worked on the novel. So we're going to divide this into fourths. I got something on the end of my pen here. Alright, so we're going to divide this into fourths. And I'm just using a dashed line just to kind of divide this. Okay. So we can see that 8 printing presses worked on the novel job on day 1. Okay, so day 1, we can see that 8 printing presses, day 1, 8 printing presses worked on the novel. Okay? I'm going to have to back this out just a little bit so that we can see. Okay? Which was all the printing presses. Alright, so there are 8 printing presses at the print shop. Because if you remember, it says all the printing presses were working on the novel on day 1. Alright? So all the printing presses that are there are 8 printing presses at the print shop. Okay? Alright, now let's look at part B. It says solve it by setting up an equation. Okay, so let's kind of walk through this. I think setting up equations are a little easier, but we will see. You might like the area models better. Okay, so let's talk about the variables that we need to know. Okay, so the number of printing presses, this is what we're trying to find. We're going to let that be x. Okay? So we're going to let x represent the number of printing presses, which is what we're trying to find. Okay. So then we've got the number of copies of cookbooks that were printed in one printing press in one day. Alright, so number of cookbooks. And I'm going to abbreviate CB for cookbooks. Alright, so the number of copies of cookbooks printed by one printing press in one day. Okay? And we're just going to let R represent that. This is the number of cookbooks that are printed by one printing press in one day. Okay, now let's talk about this. The number of copies of novels printed by one printing press per day. Okay, number of novels printed by one printing press in one day. Now, if you remember, it said the novel takes twice as long. So if I print R number of cookbooks, that means I'm only printing half the amount of copies. So we're going to have to let 1/2 R represent the number of novels that we're printing. Alright, so now we want to talk about the total number, the number of copies in the cookbook job. And we'll just let that be C. We'll let C represent that. And the number of copies in novel job, remember it said that they were the same amount, so we're also going to have to let that be C. Okay, because it said we had the same number. Alright, so now let's think about important expressions. Alright, we're going to talk about expressions that we need to write down using this information. Okay, so let's talk about how would I find, let's deal with novels first. We're going to break this down into novels. Alright, so how would I find the number of copies of novels in one day by the entire print shop? Okay, so I want to know what would I have to do in order to figure out the number of copies of novels printed in one day by the entire print shop. Well, we said that the number of novels that were printed in one day by one printing press is 1/2 R. And the number of printing presses are X, so I would multiply 1/2 RX. And that would tell me the number of copies of novels that were printed in one day. Alright, so the number of copies Alright, let's look at the number of copies of novels printed. In one day by half of the printing presses, or the entire print shop. Alright. Well, if it's already 1/2 of that, so I have to take 1/2 of that, that would be 1/4. 1/2 times 1/2 is 1/4 RX. Alright, now, how do I find the total number of copies of novels printed? I want to know the total number of copies. Well, how much was printed in one day by the entire print press? Because remember, day one, it said that every print press was working, so 1/2 RX. And then day two, it said only half of those were working, so I would add that. So I would add 1/2 RX plus 1/4 RX, or if I change those two common denominators, I would get 3/4 RX. Okay, so that's how I'm going to find the number of novels. Alright, let's look at the number, let's deal with our cookbooks here. Alright, so now we're looking at cookbooks. Alright, so the number of copies of cookbooks. In one day by half of the entire print shop. Alright, well, we said that the number of print by one printing press was R. So in order to find half of that, I would do 1/2 R times X. Alright, so the number of copies of cookbooks printed in 2 days by one printing press well, if it's 2 days by one printing press, if they're printing R each day, that's 2 days, so 2R. Alright, so how do I find the total number? So the total number of cookbooks printed would be 1/2 RX plus 2R. Okay, so since the number of cookbooks in the novel is the same as the number, or I'm sorry, since the number of cookbooks and the number of novels are the same, we can write our equation, we can equate the expressions of the totals that we get. Alright? So we can look at it like this. 3/4 RX is equal to 1/2 RX plus 2R. Okay? Since R is known not to be 0, we can divide both sides by the equation by R and solve the resulting equation for X. So we can divide both sides by R since everything has an R in it. If I divide R by R, that's gonna basically be a 1. So I end up with, so I'm dividing by R. Alright, that cancels them out because it's 1. So I'm left with 3/4 X plus 1/2, is equal to 1/2 X plus 2. Alright, so now we can solve this. Guys, you can get rid of that denominator. I would multiply everything by 4. That would be my suggestion because that's a common denominator. So I get 3x is equal to, 2 goes into 4 2 times, so 2 times 1 is 2, plus 8. Subtract your 2x. I get x is equal to 8. Alright? I can look at this and make sure. I can plug this back in to my equation and see if it works. But I would figure out that there are 8 printing presses in the shop. Alright? Which is what we figured out back here. Okay? Alright guys, that is pretty much the lesson. Have a great rest of the week.